Good morning, students. So this is my second video on indefinite integration. Before this, I made a video on indefinite integration. In that video, I have given introduction and standard basic formulae. Okay, in this now we will discuss further. So after completing basics of integration, we have collected about 27 basic formulae. Those are important. I asked you to go through. Now we will discuss further concept. Listen. Methods of integration. Methods of integration. Yes, after completing that basics, now we will see the different methods. There are mainly four methods. There are mainly four methods of integration. What are those four? First one is integration. First one is integration by the method of substitution. By the method of substitution, which is also known as change of variable. Change of variable. This is first method. Yes. Next, second method. Integration by the method of partial fractions. By the method of partial fractions. This is the second one. Next, number 3. Integration by parts. Integration by parts. Next, fourth one is integration by successive reduction. Yes, these are the main methods of integration. There are four main methods. What is first one? First one is integration by the method of substitution. This one, integration by the method of substitution, which is also known as change of variable. Second one is integration by the method of partial fractions. So in the second method, we use partial fractions. So to learn this second method, you need to know partial fractions. Already I have made 2 conceptual videos on partial fractions. I have explained about all the types. There are about 5 types. So in this video, I will be handling substitution method. My next video will be on partial fractions. If you want to understand this second type, integration by the method of partial fractions, you should aware of partial fractions. Meanwhile, you complete this concept. It is a very small chapter. There are only 5 types. If a fraction is given, how to split it into partial fractions. You complete that. Next, third one is integration by parts. That is, product rule, integral uv, that is integration by parts. Next one is integration by the method of reduction, successive reduction. Okay, today we will discuss integration by the method of substitution. Before starting that integration by the method of substitution, I want to say that please follow in order, no confusion. So far what we did, we have collected about 27 basic formulae. Okay. Now onwards, by these methods we will be finding some more, we will be adding some more concepts to those 27. Okay. Let us begin integration by the method of substitution. Yes. Let us start integration by the method of substitution. Yes, this is what integration by the method of substitution. Substitution. Listen carefully. Okay, please listen. If integral of a function f of x with respect to x is another function capital F of x plus c. See, f of x is a function whose integral is capital F of x plus c. If integral of f of x is capital F of x plus c, what is this f of x? It is a standard integrand. That means one of the 27 formulae. Okay, right. So in this function, in this standard integrand, variable is x. Now if you have given instead of x f of ax plus b into dx, then how to work out this? How to solve this? Are you following? What is this? This is one of the 27 integral formulae. F of x is integrand of one of those standard models whose integral is given this. Okay, now we are going to find f of ax plus b. How to find this? So we already, for the same function f, we know the integral at only x. Then if something other is there, how to get it? This is. So since we know the integral of f at x, single variable, I will take substitution. I will suppose integral, not integral, ax plus b is equal to t. This is known as substitution method. Differentiate here a into x derivative. In generally, what is x derivative? X derivative is 1, but here you should write dx. B is constant whose derivative 0, t derivative which is partial dt. So this implies dx is equal to dt by a. So I have taken some substitution. By taking this substitution, this integral becomes integral f of, I have taken ax plus b as t, single variable. What is dx? Dx is dt by a. Since a is constant, I can place outside the integral. It is now coefficient. Therefore, this is what now? 1 by a into integral f of t, single variable. When single variable is there, integral f of x dx is what? Capital F of x plus c. I can apply this. Therefore, this is what? F of t plus c. F of t plus c. Therefore, integral f of ax plus b into dx, its integral is 1 by a into capital F of t, but in the question t has not given. We have introduced t, again replacing the original x. What is t? T is ax plus b plus c. This is the integral. See, integral f of ax plus b dx is equal to 1 by a into this. We have obtained this. This is a concept. Now we will see what is this concept. Once again, listen carefully. I said f of x is a standard integrand whose integral is known. For 27 standard integrands, we know their integrals seen in the last video. Okay. Then what about f of, instead of x, here what we have? Ax plus b. What is ax plus b? It is a linear factor. This is important. In place of x, we have linear factor. Then what happened? Its integral is same concept, same formula. F of x is capital F of x. Here small f of ax plus b is capital F of ax plus b. What has come extra? This linear factor's derivative is small a. What is derivative of this? Ax plus b. Derivative is a. That derivative comes in the denominator. That's all. Same thing in differentiation. For example, if you are differentiating ax plus b, what is its derivative? Generally, its derivative is a. If you have ax plus b whole power n, a composite function, what will be its derivative? N into ax plus b whole power n minus 1. That is, I have supposed this as x and I applied x power n. This is the derivative. But in place of x is not there. Some other thing is there. Again, I have to multiply this by its derivative. In the differentiation, we multiply with the derivative. But here, you are supposed to divide with the derivative of this. And I will state an important point here. If you have linear factor, then only this is applicable. Once again, using any formula of 27 standard formulas, in place of x, if you have a linear factor, then you can use this. This is applicable when this is only linear factor, whereas integration is applicable for all. But in the integration, it is applicable for only linear factor. Please see. I will take one example. Integral e power 2x plus 3 into dx. Yes, what is this? For this, its standard integrand is e power x. For e power x, we have formula. So, what is there in place of x? It is a linear. Since it is linear, this procedure, this concept is applicable. What is its integral? E power x integral is e power x only. What to do now? Dividing by derivative of this linear factor. So what is derivative of 2x plus 3? It is 2. So divided by 2 plus c. Okay, this is the procedure. We will see another example. integral 1 divided by 3x plus 1 into dx. What is this? This is a linear factor again. So it is similar to 1 by x. What is integral of 1 by x? Log of mod x. You can apply that. So this is log of mod x, that is 3x plus 1. But here x is not there. In place of x there is a linear factor whose derivative is 3. Therefore here we will get divided by 3 plus c. This is the way of finding the integrals of standard integrands when they have something other than x. What is other than x? Linear factor only. This is very important. You please see one more example. If I have integral x square plus 1 into dx. If I adopt the same, this will be e power x square plus 1. Its integral is what? 2x. This is not true. You should not apply this because here this method is applicable. This concept is applicable for only linear. This is not linear. This is not linear. Therefore this method is not applicable. Did you understand? This method is applicable for all 27 basic integrands when they have linear factor in place of x. Only linear. If it has quadratic, cubic, other factors, this should not be applied. Like this you should not do. Okay? So therefore, by this concept, we have come to this conclusion. There are 27 basic integrands, 27 formulae. All those are in single variable x. Yes, this concept says that those 27 integrands can be extended to this. If a linear factor is there in place of x of those 27, those integrals will be found in this way. Same formula will applicable. What has to be done? If the linear factor is there, no, its derivative comes in the denominator. Is it clear? Yes. Now we are in method of substitution. We will see one more. Please see. Number 1. Integral f dash x divided by f of x into dx. Yes, this is another integral. Listen, here I will take the substitution. F of x is equal to t. If I differentiate this, f dash x dx is equal to dt. By taking this substitution, this becomes integral of, what is f of x? We have taken f of x as t. This f dash x into dx, it becomes dt. See how this substitution method works. This is the given integral. At the moment we don't have any u by v formula. Therefore I took substitution and I made it standard integrand 1 by x model. Therefore it has integral, which is log integral 1 by x is log of mod x plus c. Therefore what is this? Integral f dash x divided by f of x into dx. This is equal to log of mod t. T is not given in the question. we have taken in our substitution. Therefore, the original has to be replaced plus C. So this type of problems, this type of models, while doing problems, they come very frequently. Therefore, we will take this as a formula. Yes, I will write in the box. Yes. What is this formula? Integral f dash x by f of x dx is log of mod f of x. This can be applied when the integrand is of this type. But you should remember, don't forget, this formula has come by substitution. While you are listening the problem, sometimes your teacher may use this substitution, or sometimes he may use this. No confusion. After first basic 27 standard formulae, now what we are proving, what we are deriving, what we are obtaining, they are all from substitution. Therefore, if you remember this, if you can identify the problem to use this one, you can apply. Otherwise, substitution. This is general procedure. Why we are taking this as a formula? There will be many problems of this type. So for all the problems, always taking instead of f of x equal to this method directly, we will use this as a formula. Okay? Right. Next one. Number 2. What is integral of f dash x divided by root over f of x into dx? Yes. Again we will take the substitution. Same substitution. F of x is equal to t. If I differentiate this, this will be f dash x dx is equal to dt. With this substitution, this given integral becomes 1 divided by what is f of x taken as t, and f dash x dx becomes dt. Therefore, what is its integral? 1 by root x, it is 1 of 27 standard integrand. Its integral is 2 root t plus c. You can replace this t by f of x because in this question t has not given. Therefore, integral f dash x divided by root over f of x into dx. This is what? 2 into root over f of x. T is f of x plus c. This can be taken as another formula. This also came from substitution only. Okay, this is also obtained from substitution. After 27 basic formulae, these are what we are deriving. They are all from substitution only. If you can use this, if you can identify the problem, then you can apply this, or simply you can proceed like this, substitution method. Next, we will see another. Number 3. If integral f of x whole power n into f dash x, if this is given, into dx. Yes, here fx is a function. In this we are also having its derivative. Therefore, you can take the substitution f of x is equal to t. Therefore, f dash x dx is equal to dt. Yes. Now with this substitution, this becomes, we have taken f of x as t, no? Therefore it is t power n. F dash x dx becomes dt. What is this now? It is a simple integrand, x power n. Formula is there for integral x power n plus 1 by n plus 1 plus c. This is its integral. Replace t by f of x. Therefore, integral f of x whole power n into f dash x into dx. What is this? It is t power n plus 1. What is t? T is f of x. Therefore, f of x whole power n plus 1 divided by n plus 1 plus c. This is another formula. This also obtained from substitution only. It is not compulsory to use this. This has come from substitution only. You can use substitution, or if you are able to identify the problem, which is given problem is of exactly this type, directly you can use this. Just now we have obtained 3 formulas. Those have come from substitution. You can add these 3 formulas to the list. Already we have made a list of 27 formulae. These 3 can be added to that list. Lastly, once again I will remind this point. Okay. In the standard integrands, we have find integrals for sin x, trigonometric, sin x, cos x, secant square x, cosecant square x, sec x into tan x, cosec x into tan x. In the basics, we did not find tan x, we did not find cot x, sec x and cosec x. Now we will see. Now we can able to find their integrals. See now. What is integral of tan x into dx? Okay. Please listen. This is equal to integral of, I will write this as sin x divided by cos x into dx. Okay. So for cos x derivative is sin x. Therefore, there is no u by v here. Therefore, I will adopt substitution method. I will let cos x equal to t. What is its derivative? Minus sin x into dx is equal to dt. Therefore, sin x dx will be minus dt. Why I wrote like this? Here we have only sin x dx. Minus is not there. Therefore, this is integral. We have taken cos x as t. And sin x dx is what? Minus dt. Minus means minus 1. It is a constant number, can be written outside. Okay. Therefore, this is minus of, what is this 1 by t? Standard integrand 1 by x. It has integral no, log of mod t plus c. Yes, minus of log of mod t. T is not given in the question. What is our original t? It is cos x plus c. So minus is there. This minus means minus 1, which is the coefficient of logarithm. We know coefficient of a logarithm becomes power of the number. So this is now log of cos x whole power minus 1. That means 1 by cos x. 1 by cos x is what? Sec x plus c. Therefore, the integral of tan x into dx. It is log of mod sec x plus c. This is the formula for integral tan x. This should be added to the list. Yes, this is integral of tan x. Next we will see integral for cot x. We did not find in the basics. Integral cot x dx. How to find this? Right, this integral is equal to integral of cot x is cos x by sin x into dx. U by v, no u by v here. Now I will take the substitution. Let sin x is equal to t. Then cos x dx is equal to dt. Yes, with this substitution integral, we have taken sin x as t, 1 by t, and this cos x into dx becomes dt. Yes, it is a standard integrand 1 by x whose integral is log of mod x. Therefore, it is log of mod t plus c. What is t? T is sin x. Therefore, integral cot x into dx is equal to log of t. What is t? T is sin x plus c. So this is the integral of cot x. This can be also added to the list. This is formula for tan x. This is for this. Once listen, no confusion. Here I have obtained this by the method of substitution. Okay, you please see. Now I will do this as integral cot x into dx is equal to integral cos x divided by sin x into dx. Okay, here cos is there in the numerator, sin is there in the denominator. Directly you can write it as log of mod sin x. How I wrote this? Because I have supposed sin x as f of x. Then what is cos x? It is f dash x. Therefore, I have used this formula. F dash x divided by f of x into dx. Just now we have seen what is integral f dash x by fx, log of f of x. That's what. This is f dash x, this is f of x. Integral f dash x by fx is what? Log of f of x. That's all. Here generally some students, they may get confused. No confusion. After 27 standard integrands which we have already written a list, now these are all obtained from substitution. You can apply both. You can apply this substitution method. Using substitution method, we are deriving some formulas. You can use those formulas also. When to use this, your choice. No restriction, no confusion. Okay? Right. We did not find integral for sec x in the basics. Now we will see integral sec x into dx carefully. Now is it clear? Using these formulas, f dash x by fx or f dash x by 2 root x, they are absolutely your choice. You can, if you are able to use those, you can use. Otherwise, you can go with substitution. Okay, how to find its integral? See now. integral sec x. I am multiplying and dividing by sec x plus tan x. In integration, it is a formula based chapter absolutely, but together with the formulas, logic, common sense is required. Okay, now you please see what is this. Numerator is secant square x plus sec x into tan x whole divided by sec x plus tan x into dx. You see this fraction. In the denominator, sec x plus tan x is there. What is the derivative of sec x? Sec x tan x plus tan x derivative is secant square x. Therefore, I can take this as f of x. Then what is this numerator? F dash x. Now what it is? It is integral f dash x by fx. Can I apply integral f dash x by fx? Yes. What is integral f dash x by fx? It is log of mod f of x. Therefore, this is the integral. Integral sec x is log of sec x plus tan x. I obtained this by using f dash x by fx. No confusion. If you can use this, use. Otherwise, go to substitution. What is the substitution? You take this as t. Then this will be dt. You will get 1 by t. 1 by t integral is log of mod t. That's all. So here you please see what is there. Log of sec x plus tan x. This is the integral of sec x. We will simplify this and see. Log of sec x is 1 by cos x. Tan x is sin x by cos x. Yes, this is equal to log of 1 plus. I will write this sin x as cos of pi by 2 plus x. Then I should take minus here because cos 90 plus theta minus sin theta. But here plus is there, no? I have added minus. And what about denominator? Denominator is cos, no? I can write it as sin of pi by 2 plus x. Why I am doing this? I will tell lastly. Okay. Sin 90 plus theta is plus cos theta only. Yes. Now what is this? Log of 1 minus cos 2a. 1 minus cos 2a is 2 sin square a. That means 2 sin square. A means half of this. In the denominator, I will use sin 2a formula. It is 2 sin a. A means half of this. 2 sin a into cos a. Yes. Now I can cut 1 sin pi by 4x by 2. There are 2, no? I can cut 1, 1. And also I can cut this and this. Therefore, what this is? This is log of. We have 1 sin in the numerator, cos in the denominator. Therefore, tan of pi by 4 plus x by 2. What is this? This is equal to this. What is this actually? It is the integral of sec x. So this is the integral of sec x. Integral of sec x is log of sec x plus tan x, which is absolutely true. Then why I made this? Why I have done this? Because In objective, answer will be in this form for many problems. That means answer will be given in this simplified form frequently. For that only I have done now. Therefore, finally, now you please see integral of sec x dx. It is equal to log of sec x plus tan x plus c. You can use this. It is also equal to log of mod tan of pi by 4 plus x by 2 plus c. In descriptive questions, you can apply any one. Generally, we apply first one only. In objective, you should watch the options. In objective, what happens? You are supposed to get the answer which is there in the options. So, watching options, if this is required, you apply this. This is required, apply this. So, this is the formula of integral sec x dx. Added to the list. This should be added to the list. Yes. Yes. Next we will see the integral of cosec x. See now. Integral of cosec x dx. In the basics, we did not do this. Okay. This will be done like this. Integral cosec x is there, no? I multiply and divide by cosec x into, cosec x minus cot x. Into dx. Now, this is equal to integral cosec square x minus cosec x into cot x divided by cosec x minus cot x into dx. U by v. See. What is the derivative of, listen carefully, what is the derivative of cosec x minus cosec x cot x? Okay. Then what is the derivative of cot x? Cot x derivative is minus cosec square x. But here minus cot x is there. Then derivative of minus cot x will be plus cosec square x. That means if denominator is a function f of x, what is the numerator? It is f dash x. Therefore, again I can apply f dash x by fx. Integral f dash x by fx dx is what? Log of f of x. That's all. Therefore, what is this? This is log of f of x. F of x is cosec x minus cot x plus c. This is the integral. For this also, take this integral, which is integral of cosec x, no? This can be simplified. This is log of cosec x is 1 by sin x and this is cos by sin x. Therefore, 1 minus cos x by sin x plus c. I am simplifying the answer. Log of 1 minus cos x using cos 2a. This is what? 2 sin square x by 2. And denominator by applying sin 2x. 2 sin x by 2 cos x by 2. I can cut 2 and 2, 1 sin and 1 sin x by 2. We will have what? Log of Sin x by 2 by cos x by 2 is tan x by 2 plus c. So integral cosec x dx is either this or this. Whichever you require, you can take that. Therefore, here integral of cosec x dx is, what is its integral? Log of cosec x minus cot x, this one. Or you can also take log of tan of x by 2 plus c. This is the formula for cosec x. So integral cosec x dx is log of cosec x minus cot x or log of tan x by 2. So now in this we have find number 1, f dash integral f dash x by f of x dx, integral f dash x by root f of x, integral fx whole power n into f dash x, and tan, cot, sec and cosec. So we have obtained 7 things here. These 7 can be added to the list. Okay, right. Once again, no confusion. All these, especially f dash x by fx, those are obtained by the method of substitution. Once again, I am telling, your teacher may use, some teacher may use substitution procedure, taking f of x equal to 2 like that. Some teachers may use directly f dash x by fx. No confusion. When to apply that, when to apply this, both are same. You can use your choice. Okay, right. Then in this part, we have some more formulae. There are 9 standard results, 9 standard integrals. Right. These are also important. Please see number 1. Integral 1 divided by x square plus a square into dx. Right. We will find this. Okay. You please see what is this integral x square plus a square. In standard integrals we have a formula. Integral x square plus 1 into dx. What was this? It is tan inverse of x plus c. What is there here? X square plus a square. Here variable is as it is. Constant has changed. Are you observing? Constant has changed. If variable is changed, then we will see if it is linear. We have seen a procedure. But here constant has changed. No? Okay. Now we will see how to solve this. Using substitution method. I will suppose x equal to, if this expression is x square plus something, then you should take the substitution tan theta. If minus a square minus x square like that, then you should take sin theta or cos theta. If plus is there, tan theta or cot theta. So here x square plus a square is there. Therefore I take the substitution x equal to a tan theta. Why I have taken this? When to take this substitution? When to take tan? When to take cot, sin, cos, etc. There is a list in the textbooks. You go through that. Lastly, I will also explain that. Okay. I have taken this. Now what is its integral differentiating this? Dx is equal to a is coefficient, tan derivative is secant square into d theta. By taking this substitution, this becomes, see carefully, what is dx? What is numerator? 1 into dx means dx. Here I have a secant square theta into d theta divided by, our substitution is a tan theta x square, that is a square tan square theta plus a square. Okay, this implies integral of a secant square theta d theta divided by, I can take a square common. If I take a square common, I will be having tan square theta plus 1. What is tan square theta plus 1? It is secant square theta. Therefore, I can cut secant square, secant square. I can also cut a and a. What will be there? Here only a will be there in the denominator. Here nothing is there. That means 1 into d theta. Therefore, 1 by a into, what is integral of 1? Integral of 1 is x with reference to x variable. Here variable is theta. Therefore, its integral is theta plus arbitrary constant c. But theta is not given in the question. Theta is not given. So what is theta from that? This is our substitution, no? So I can write x by a is equal to tan theta. If I want theta, I should write tan on other side. It becomes tan inverse. This is theta. We will replace here. Therefore, this is what 1 by a into theta is tan inverse of x by a plus c. Okay. So this is the integral of this. See now. So therefore, one more new formula has come. Integral 1 divided by x square plus a square into dx. What is this? It is 1 by a into tan inverse of x by a plus c. One more formula can be added, must be added of course, to the list. Okay, similarly there will be two more you can do in the same approach. Integral 1 divided by, here x square plus a square is there, no? There will be another formula, x square minus a square into dx, whose integral will be 1 by 2a into log of x plus a divided by x minus a, not x plus a, x minus a divided by x plus a plus c. And one more, integral 1 divided by a square minus x square into dx. This will be 1 by 2a into log of a plus x by a minus x plus c. There are three formulas when the numerators are 1 and denominators are in terms of x square and a square, no square root. If square roots are there, they are some other different formulas. So these are the three more formulas to be added to the list, as well as these are the three, as well as you are supposed to learn these three. These are three more formulas to be added to the list. Just now we have find the three integrals which are 1 by x square minus a square minus x square plus a square. I said there are 9 standard integrals, obtained 3. Next I will see another integral 1 divided by root over a square minus x square into dx. What is the difference? We have seen this in the previous 3, but there was no square root. There was only 1 by a square minus x square. Yes, there will be, in the beginning there will be a lot of confusion. It is common for every student. Nothing to worry. Just you go on practicing these. You prepare that list. Firstly, 27 formulas have come. Today, firstly, I made 3 formulas. Then tan, cot, sec, cosec, 4 formulas. Now 9. 27 plus 3, 30. 30 plus 4, 34. 34 plus 9, 43. These 43 are enough. If you are thorough with these 43 formulas, integration is over. For upcoming next exercises, only procedures will come. Same, they all depend on same these formulas only. Be careful, huh? Right, I will find the integral of this. A square minus x square. For such, my substitution will be x is equal to a sin theta or cos theta. What is dx now? Dx is equal to a into cos theta d theta. Yes, with this substitution, this becomes, what is numerator? 1 into dx. In place of dx, I can write a cos theta into d theta. In the denominator, what is there? A square minus x square. X is a sin theta. X square is a square sin square theta. Yes, let us simplify. A into cos theta d theta. Now see what is denominator. I can take a square common. Square root of a square is a. After taking a square common, what will be there in the root? 1 minus sin square theta, cos square theta. Root over cos square theta is cos theta. Therefore, cos theta, a gets cancelled. I will have only 1 into d theta. Yes. What is integral of 1 with respect to theta? It is theta plus c. What is theta? Theta is not given in the question. From this I have to find theta. X by a equal to this. From this theta equal to sin inverse of x by a. That's all. So if I write theta here, this is what? Sin inverse of x by a plus c. This is the integral of this. Right. So we obtained a formula here. Integral 1 divided by root over a square minus x square into dx. What is it? It is sin inverse of x by a plus c. Okay, this is one more. Similarly, there will be 2 more of the same fashion. 1 divided by root over a square plus x square. A square plus x square or x square plus x square. When plus is there, both are same. Its integral will be sin h inverse of x by a plus c. And one more, integral 1 divided by root over x square minus a square into dx. This will be cos h inverse of x by a plus c. These are the three more. I have done first one. Similarly, these two can be derived. So these are three more formulae. These 9 standard integrals are very, very important. They are only gets confused. Yes, these are the three new formulae to be added to the list. 9 standard integrals. We have seen 6 of them. Now next one. What is next one? Integral of root over a square minus x square into dx. All the 9 are in terms of a square and x square only with different combinations. Let us see. It is in the numerator. Previous 6 integrals, they were 1 by. Now again a square minus x square. My substitution is x is equal to a sin theta. Therefore, what is dx? Dx is equal to a cos theta d theta. Okay, with this substitution, the given integral becomes root over a square minus, what is x square? A square sin square theta. And what is dx? Dx is a cos theta d theta. Okay, let us simplify this. Integral of, if I take a square common, its square root will be a. Already a is there. That means a square, which is a constant, can be written outside. What will be there now? Root over 1 minus sin square theta. Cos square theta. Root over cos square theta is cos theta. Already we have a cos theta here, therefore it becomes cos square theta. Yes, a square into integral cos square theta. In the standard integrals 27, we have integral for cos theta, cos x we have, but cos square we don't have. For squares, it will be coming in the last exercise. Okay, I will simplify this. I can write cos square as 1 plus cos 2 theta by 2. What I did, I have applied a formula of multiple submultiple angles. I have removed the power. This 2 is a constant. It can be written outside. Now what is there? Integral of 1 plus cos 2 theta into d theta. Yes, now this is a square by 2 into, this is integrable. 1 is a constant number. What is integral of 1? It is x, when variable is x, but here variable is theta. Therefore it is theta. Now listen carefully. What is this? Cos 2 theta, no power. So in place of x, 2x is there. That means in place of, if a theta is there, cos theta is standard, cos x is standard. 2 theta, 2x is there. What is 2x? It is linear. Therefore, I said in the beginning, same formula can be applied, but you should divide with its derivative. If I do that, what is derivative of cos? It is sine. Here only theta is not there. Linear, 2 theta is a linear whose derivative is 2. Therefore by 2, that's all, plus c. Okay, therefore, but in the question theta is not given, no. So we should obtain this in x. Theta. What is theta from this? Sin theta is x by a. Theta is sin inverse of x by a. Plus sin 2 theta is there. I will write it as 2 sin theta cos theta. 2 will be cut. Plus c. See, therefore this is equal to a square by 2 into sin inverse of x by a plus sin theta. What is sin theta? X by a. Cos theta. What is here? Here sin theta is x by a, no? Therefore, if you know sin theta, you can write cos theta. Cos theta is 1 minus sin square theta, which is nothing but root over a square minus x square by a. So, in place of cos theta, I can write root over a square minus x square by a plus c. This is the integral. This is the integral of this. I will write here clearly. You please see. First one. Integral root over a square minus x square into dx. What is it? This is the integral. I will multiply this and I will write this first. Here a into a is a square. If I multiply with this, a square will be gets cancelled. I will have x by 2. So the formula is x by 2 into, what is the formula? X by 2 into root over a square minus x square. Then you take this a square by 2 into this. A square by 2 into sin inverse of x by a plus c. Yes, this is one more formula. Very, very important. Yes. Similarly, you can take two more. What is other one? Integral root over a square plus x square. A square plus x square or x square plus a square. Both are same. Its integral will be x by 2 into root over given function as it is. It comes as it is. A square plus x square plus a square by 2 into sin h inverse of x by a plus c. This is second one. There will be one more. Root over x square minus a square into dx. What is this? X by 2 into same given function x square minus a square. Here you should remember minus a square by 2 into cos h inverse of x by a plus c. These are the three more formulae to be added to the list. That's all. Almost we have completed important formulae. There will be some more, but they are simple. These only very, very important. Yes, these are the three more. Totally now I have obtained 9 in terms of a square and x square. Listen, whenever a square minus x square is there, it is related to sin inverse. When plus is there, related to sin h inverse. You see the previous three formulas also. X square minus a square related to cos h inverse. Whenever You have an sin h inverse, cos h inverse in the formulae. Instead of inverse functions, you can also write their log. In hyperbolic functions, we have seen what is sin h inverse of x, what is cos h inverse of x. Those can be written in logarithmic functions. In place of this, you can replace log of x plus under root of x square plus a square like that. So these are the three more. Listen Nana. So far, first in the basics we have done 27. Today f dash x by fx, f dash x by root fx whole power n into f dash x. I have made three more. Then tan x, cot x, sec x, cosec x. Again I have obtained four formulas. Then these 9 special standard formulas. What is the total? Total comes to about 43. These are the 43 important formulae of integration. These formulas are only very important. In further exercises, you will find only procedures. Everywhere, these only useful. Okay? Right.